So your homework for your transformations, graph your core graph, and then graph each one from the core graph and describe the transformation. We start with your squaring function. The +2 on the outside gives you a vertical shift up 2. Inside by the x gives you a shift to the right 2 units. This one begins with the squaring function that is already reflected. This black one here is already reflected over the x-axis. Then we take this and we +1. We bring it up 1. Then we take 2 off from the inside, which shifts it to the right 2 and ends in the green. Again, your your squaring function. These have non-rigid transformations. The 1/2 causes a shrink. It's less than 2. Now, the 2 outside, be careful because it's being raised to the second power. So 2 squared is actually 4x squared. This is going to look like. This is going to give you a vertical stretch by a factor of 4. It's going to pull your graph up. Your absolute value functions work the same way as your squares. Your squaring. Start with your absolute value, you subtract 1, you shift it down. Inside the absolute value is the same as inside the parentheses. It's taking a horizontal shift the opposite way, right 3 units. In this problem, you're actually using your graph to define your function. They want you to take the original function, which is in black, and shift it 2 up. Vertical shift up 2. You're going to take every point and shift it up 2. So I've written all the points out here, and I've shifted it up 2, which means to the y, you're going to add 2. So to every y, you're adding 2. And you're coming out with these new points. And that I graphed over here. On this one, you're going to take your original function, which is in the black, and you're going to reflect it. Because it's changing the y, it's going over the x-axis. Use your rules. It's more helpful that way. If you can, by eyesight, bring this down. If not, use your rules. Negate the y. There's your new points, and graph them. The next one works the same way. It starts off of an original function. This time they want you to make a horizontal shift right 2 units. You take every point and you move it to the right 2 units. It's easier to do it by point. If you're going to the right, you're changing the x. So you're adding 2 to the x each time. In the second part of it, you're going back to your original, the black one right here in the line, and you're taking 3 unit shift to the left. So it's easier to subtract 3 from the x value. Take 3 away from your x value, and then you'll get your new function. In 7 and 8, you're identifying your parent graph for your core, and you're describing the transformation. So our parent graph is your squaring, and it resulted in a shift down 1 unit, and again, our domain and our range. Your parent graph in this one is an absolute value, and since it went to the left, we put +2 inside and your domain and your range. In these next 4, sketch your parent graph first. This one gives us a reflection over the x-axis because it's affecting your y. Sketch that. Sketch your squaring. It's inside here now, so it's saying take x and negate it. So from here to here, it results in the same graph. Here's your rational function. You're negating x. So by negating x, you're having a reflection in your y-axis, which results in this new red one. And this one is a dilation, a non-rigid transfer, in which, because this factor is a 1/4, it means you're getting a vertical shrink by a factor of 1/4.